my goodness! Welcome to Trig! Yay! We're doing Trig right now. Hey, so will you define angle? Just, what's an angle? Goodness knows, you've been talking about angles for years. You should be able to tell me what angle is. Okay, so, yeah. You just said a number of things that are true. But, yeah, very few people remember our definition. Our definition from geometry was two rays and the amount of rotation between them. And that feels a little bit like, what? Yeah, so, right. So, angle. The amount of rotation between rays that share an endpoint. And thus, this. There's a ray, they share an endpoint. And what I'd really like you to do is imagine that you've got this ray and that you're rotating that ray. Okay? So that's a little different. I mean, we're so used to talking about, there's my angle. And I know that these three angles will add up to 180. That doesn't tell me what an angle is. And because we're talking about this amount of rotation thing, well, rotation is this really interesting thing. Because I can rotate to here, I could rotate to here, but I could also rotate to here. And that gives me that nice big reflex angle. But here's my initial ray. I could also rotate like that. And that's really different, isn't it? That's a lot of rotation. So, I need to understand angle in a new way. Okay? My angle is going to have, just so you don't think I'm misleading you, we're going to have an initial side and a terminal side. Okay. Terminal side. And my rotation starts here and goes that way. Well, the cool thing about defining angle in terms of rotation, that rotation can be counterclockwise, but it could also be clockwise. And that's a negative angle. So now we're going to talk about rotating in a positive direction for a positive angle, and rotating in the opposite or negative direction to get this negative angle. That's very exciting. In fact, I kind of want to blow your whole mind away by saying degrees. Yeah. No, not so much. I mean, don't get me wrong. We'll still use degrees in this class of trig, but degrees isn't the most common. Degrees isn't the one that is the main. If I turn on my calculator and I press mode, which comes first, degree or radian? These calculators come from the factory set in radians, not degrees. So, guess what? We need to talk about radians. Because anytime we're doing any trig function graphing, gonna be in radians. A lot of what we're gonna do is gonna be in radians. All of calculus is gonna be in radians. We're not gonna do degrees. Okay? So, we need to know what both of these are. And I understand that if I'm thinking about radians, I'm thinking about an amount of rotation. Actually, I want to hold off on that for a minute. Let's just go back. Yeah, let's just go back and talk about, I really want to get into coterminal angles. Yeah, a little more vocabulary first, and then we'll talk about radians. So we said that positive angles, that's when we're rotating that way, counterclockwise. And negative angles, that's when we're rotating. Yeah, that's counterclockwise. Rotating clockwise. So a negative angle goes in that direction. Okay. The thing I had sort of skipped by, and this is actually, for a lot of years I thought, who cares about this? It turns out that coterminal angles, it's really kind of terribly helpful to know coterminal angles, especially when we get into solving trig equations in chapter 5. So what are coterminal angles? Coterminal angles are two angles that share an initial side and a terminal side. Okay, and what does that mean? Well, let's take a look. I've got an angle here. And by the way, that's a theta. You know how we used x for the last, 8 years? We could use an x here to say the measure of that angle. But more commonly, you're going to see a theta, or maybe a phi, or maybe a beta. Yeah, so we're going to be naming these angles different ways, just like we would maybe see y squared plus 4y plus 3 equals 0. You know, we didn't always use x's. Sometimes we said, hey, let's throw a different letter in there. Well, with angles, the most common letter that we use to describe angle is theta. And the second most common will be phi. Okay, so here's my initial side. Here's my terminal side. This is my angle, my amount of rotation. Well, this says that coterminal angles are angles that share an initial side and a terminal side. So I want to draw another angle here that starts here and ends here. And the exciting thing is to ask people to go to the board and do this in the classroom. Because there's some really great things that students do. So some students say, well, Mr. Cuckoo, you just told me that I could rotate. Like this angle's rotation stops here. But what if I don't? What if I go and rotate and rotate and rotate and rotate until I get back again? Yep, that's good. Those are coterminal angles. Okay. Could I do this one? No. Why not? Because coterminal angles share an initial side, but they're also supposed to share a terminal side. So keep going with this little red guy until you get here, and then yes, those could be coterminal. Great. But then somebody remembers negative angles. I want to start in the same place. I want to go in the opposite direction. They have the same terminal side. They have the same initial side. So coterminal angles are angles that have the same initial side and same terminal side. And there are an infinite number of cases. Like there's one negative one, but here's another negative one. Okay, I mean, you just keep spinning around and you'll get another one. So coterminal angles. And it turns out coterminal angles is going to be useful in this Trig Basics unit, but not this week. Probably next week, or maybe the end of this week. A few days from now, you'll be using, or you could be using, coterminal angles to help you. And then again, when we get into Chapter 5, solving trig equations, yep, that's going to be definitely another place where you're going to want to be comfortable with coterminal angles. Now, let's go deal with this thing called radians. Radians reign supreme. Radians, degrees, yeah, we like you degrees, but you know, you're not what all the cool kids use. Okay, so what's a radian? Well, so a radian is the measure of the central angle that intercepts an arc S of equal length to radius r. Now, what the hell does that mean? Well, you know, so they're saying to me that I've got this circle, and a central angle is an angle whose legs are radii. That's what a central angle is. Legs are radii. Its vertex is always the center of the circle. That intercepts an arc. Here's the arc, S, of equal length to r. And so we're saying r equals s. And remember, r equals s. Okay? And so that theta, when we have that situation, theta is 1 radian. Okay, now, yeah, sorry, I hate to say this, but it's remarkably few, the number of students who are able to sort of intellectually understand what this definition of radius is. All right? So instead of dwelling on this, and you can, and I encourage you to torment Mr. Paz for an explanation that makes more sense to you. But I actually kind of want to show you radians by applying radians. Okay, and think about radians as a way to measure an amount of rotation. Okay, so here's what I want to look at. I want to look at this. What's the distance from here all the way around to here? I remember we learned the formula for it. This thing is called circumference. Circumference is 2 pi r. Okay, well, if the radius is 1, then the circumference is 2 pi. Now, what does that mean? That means that to go all the way around, I've got 2 pi. All right, because remember that arc length is the same as the radius. No, that's not what I wanted to say. Yeah, and so rather than conflate, I'm just going to move on. So, circumference, good, r. Oh, sorry, that's what I'm missing. The arc length formula, S equals r theta. You used this in geometry class to find out how long that arc length was. You would take that radius and multiply it by radians, except you didn't know radians at the time, and so you had your angle in degrees over 360. Okay? And that would give you the arc length. Yes. Good. So now what I'm saying is, okay, so arc length, these are the same, right? Because if I go once around, I'm talking about a specific arc length called the circumference. So if this is the same as this, then we can set these equal to each other. 2 pi r equals r theta. And if I divide both sides by r, theta is 2 pi. Now, here's what I just got from that. My angle, if I go all the way around, circumferences all the way around, my angle, theta, is 2 pi. So if I go all the way around the circle, before you would have said something like 360 degrees is once around a circle. Yeah, 360 degrees. But now what we're saying is once around the circle is 2 pi radians. Oh, by the way, theta equals 360 degrees. Theta equals 2 pi. You know how I know that radians is the more common, more important unit of measure? Because I don't have to put any units here. When there are no units, it is understood that we're talking about radians. See that symbol? We're using that symbol to tell us that we're talking about the less common, less important way of measuring angles called degrees. More important, more common, radians. Less important because they need a symbol. Yeah, sorry. Okay, so let's think about an amount of rotation and the number of radians in it. So if I have once around, we said that was 2 pi radians. Well, what if I start here and stop here? I only go halfway around. Half a rotation, pi radians. What if I stop here? Well, that's a quarter of the way around. A quarter of the whole way around. Pi over 2. And in fact, if I stop here, this place, and you know this place, it's called 45 degrees. If I stop here, that's actually an eighth of the whole way around. And so I end up with pi over 4. And so what I can say here is these different amounts of rotation. You know, if my angle starts here and ends here, that amount of rotation is called pi over 4. If I keep rotating past and stop here, we might have called that a 90-degree angle, but I'm calling it a right angle, or pi over 2 radians, okay? So, what about these amounts of rotation? What if we rotate a sixth of the way? A sixth of the way is to here, and that's 1/6 of 2 pi, or that's pi over 3 radians. Okay, so that would be 1/6 or pi over 3. Here's another pi over 3. Here's a third pi over 3, a fourth pi over 3, a fifth pi over 3, and finally, this is going to be 6 pi over 3. And so all the way around is 2 pi. Cool. So a sixth of the way is pi over 3, and the last one that we have is a 12th of the way around, and that one's going to be pi over 6. And you should be recognizing some of these radian values now if you spent some time over the winter break working on memorizing your unit circles, because these would all be the radians given on your unit circle. Okay, so I have a sense of radian. Now, I'm looking here and I'm thinking, ooh, this amount of rotation, that's pi over 2 radians. This amount of rotation, that's going to be 5 pi over 6 radians. Yep. And if I rotate even further, maybe to here, I might be looking at 4 pi over 3 radians. Okay. So radian is a way of measuring angle as an amount of rotation. Great. So let's see if we can do something now with this language. And so I want to come back now and talk about coterminal angles. Okay? So what if my angle, and you know, almost always the standard representation is to have the initial side on the positive x-axis, and then to be rotating from there. So if I have theta equals pi over 3, can you give me another positive coterminal angle with this one? Okay, so no, that's not a different one. That's the same one. It's starting on the same initial side. It's ending on the same terminal side, but in fact, these are the same. It doesn't matter how far in or out I draw, these are the same. I need a different angle. And we said we could get that different angle by rotating. So I have to start here and stop here, but not that. That one's taken. So how about this one? Okay, now what's that angle going to be? Well, think about what we did. We're here, and we're going back to here. That's one rotation. So I know that if the original, this angle, was theta, then phi, this coterminal angle, is actually theta plus once around the circle. How many radians in once around the circle? 2 pi. Oh. So there's my little recipe for positive coterminal angles. Add 2 pi. Adding 2 pi. So if I've got theta equals pi over 3, and I add 2 pi, yes, I've got to make a common denominator there. 6 pi over 3 plus 1 pi over 3 is 7 pi over 3. That's phi. Now, you could, of course, find another positive coterminal angle by adding 2 pi again. Look, this is that person. Here they are. They went around twice. Here's the initial theta, then they added 2 pi, and they added another 2 pi. So I could just keep adding multiples of 2 pi. So beta is going to be pi over 3 plus 4 pi. It's 12 pi over 3, 13 pi over 3. Yeah, big angle. Okay, that's positive coterminal angles. What about negative coterminal angles? Okay, so we have this one. A little steeper than that. Here's our theta equals pi over 3. And I want a coterminal angle with that. You know, show me phi that is not a positive coterminal angle, but a negative coterminal angle. So I've got to start in the same place, and I got to end in the same place. So I'm going to go that way. Okay. How do I get that? Well, I know that this amount of rotation and this amount of rotation is once around the circle, 2 pi. Call that phi. So 2 pi equals theta plus phi. Well, Almost, not quite. I really need the absolute value of this. The absolute value of this angle plus this angle will be once around, or 2 pi. Okay. So we know that theta is pi over 3. 2 pi. So if I subtract pi over 3 from both sides, I'm going to get 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. Okay. So we get 5 pi over 3 equals the absolute value of phi. But since we're headed in the negative direction, I want to say then that phi is negative 5 pi over 3. Okay, so now my question is, how do I get there? Well, there are a couple ways I can show you this that are much more humane than this. This is hard on a lot of people's brain. And I show it first because it's what usually people do. I don't usually do that. And I don't think you should either. It's just what a lot of brains think you should do. I actually want to think about this. This is 2 pi. And because I went in the negative direction, I got a minus 2 pi. But now I'm thinking, okay, this is 2 pi, negative 2 pi. If I come all the way to here, I go all the way around, that's negative 2 pi. But my angle doesn't go all the way around. It goes all the way around, and then it goes back up by that amount. That. And what's my angle? Pi over 3. So minus 2 pi plus pi over 3, yep, negative 5 pi over 3. And so you can conceptualize it that way. But I think this is the most common way that students figure out how to find coterminal angles. When we wanted a positive coterminal angle, what did we do? We added an amount of rotation. We added once around. So add 2 pi to theta, and you could even say add multiples of 2 pi to theta to get positive coterminal angles. Well, guess what? Instead of theta plus 2 pi to get a coterminal angle, a positive coterminal angle, we could do theta minus 2 pi to get negative coterminal angles. And that's it. That's all you have to remember. Add and subtract 2 pi. So, what if I give you theta equals 5 pi over 6? Can you give me a positive coterminal angle for that? Well, our recipe for positive coterminal was add 2 pi. Oops, plus. So that's going to be 5 pi over 6 plus 12 pi over 6, or 17 pi over 6. Or, what if instead I had asked for a negative coterminal angle? So then I'm going to say 5 pi over 6 minus 2 pi. And that's going to be 5 pi over 6 minus 12 pi over 6. And I'm going to get negative 7 pi over 6. And what does that mean? Well, take a look at the picture. This amount of rotation, if you've spent some time using your unit circle, is 5 pi over 6. And this starts here and ends up here. This is negative 7 pi over 6. They start in the same place, they end in the same place. Same initial side, same terminal side. To get my coterminal angle, if I want a positive one, I'm going to add 2 pi. If I want a negative one, I'm going to subtract 2 pi. So, why don't you tell me one positive, one negative for theta equals pi over 6. Give me a positive coterminal angle for this, and give me a negative coterminal angle for this. Okay? Positive, negative. 5. Oh, is that too fast? Wait a few seconds. Because you'll have to make common denominators. Okay. 5, 4, 3, 2, 1. Well, if I add 2 pi to this, I'm going to have 13 pi over 6. And if I subtract 2 pi from this, I'm going to have negative 11 pi over 6. Now, there are some wicked people who will say, hey, but what about 25 pi over 6? Because if I add 4 pi to this, that's going to be that one. That's just me spinning around, not just once, but twice. So we could have lots of positive and lots of negative. In fact, there could be an infinite number. Most commonly, though, non-obstreperous students will, in fact, just add 2 pi or subtract 2 pi. Okay. What if theta is 3 pi over 4? Will you give me one positive and one negative coterminal angle in that situation? Okay, so if I add 2 pi to that, that's 8 pi over 4, so this is 11 pi over 4 for another positive coterminal angle. And if I think about that, here's 3 pi over 4. Oops. Here's 3 pi over 4. Well, if I go once around plus 3 pi over 4, right, I'm going once around, that's 2 pi, to get me back to here, and then another 3 pi over 4. So yeah, just adding once around to that gets me back. Now if I want to go negative, I'm going to subtract. That one. Okay. I'm going to subtract 2 pi from that and get negative 5 pi over 4. And visually, I'm looking at negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4. That's negative 5 pi over 4. And this is positive 3 pi over 4. Okay? What would you do with something like this? What about theta equals negative pi over 3? Okay. No, wait. Yeah, just do that. Okay. We're looking again for a positive and for a negative. 5, 4, 3, 2, 1. Well, I have 5 pi over 3 here for a positive one. This is negative pi over 3. And that's the same as 5 pi over 3. Good. But what about the negative coterminal angle? Well, for that one, I'm subtracting 2 pi. Minus pi over 3 minus 2 pi is going to be minus 7 pi over 3. Okay? If I think about it this way, here's my negative pi over 3. Okay, I'm going to go once around in the negative direction. That's negative 2 pi. Oops. Here, I'm going to go once around, but then I'm going to go back positive pi over 3. So I have negative 2 pi plus a pi over 3. And that's my, I don't like that at all. We're doing that. And I want to go from here to here. Yeah, that's negative 5 pi over 3. I don't know what this is. This is crazy talk. No, that's right. Is it? I add 2 pi to that. I get that. And if I subtract 2 pi, I get that. Why is my brain not firing right on this? Let's try again. Okay, so here's our angle. Here's our angle. Negative pi over 3. And I'm looking for something. Oh, I'm looking for something coterminal to that. There we go. So that's my negative 7 pi over 3. Good. And if I just go in the positive direction from here to meet this, that's my positive 5 pi over 3. Okay, good. So, positive, negative, coterminal angles. Fabulous. Let's take this a little further. Before you might have said 0, 90, 180, 270. And you might have thought about, this quadrant is all about 0 to 90 degrees. And this quadrant, and this quadrant would be 90 degrees to 180 degrees. And this one would be 180 to 270. And this is going to be 270 to 360. Yeah, that's great. Except that really we don't use this a whole lot. Instead, what we see is quadrant 1 is all about 0 to pi over 2 radians. And quadrant 2 contains pi over 2 to pi radians. And quadrant 3 contains pi to 3 pi over 2 radians. In quadrant 4, we have angles that go from 3 pi over 2 to 2 pi. Okay? In fact, let's go back and redefine some words from middle school. Certainly from geometry class. Let's define obtuse, acute, straight, and right angle. Okay, so in geometry class, we said a right angle was an angle of 90 degrees. Well, yeah, I think you still need to know that. But the cool kids are saying a right angle is pi over 2. No radian symbol. Needs a degree symbol. Not as cool. Good. And a straight angle? Well, an angle of 180 degrees. Well, what's that look like for us? Straight angle. Here's our straight angle. Our straight angle is pi radians. An acute angle. Well, an acute angle is between 0 degrees and 90 degrees. Well, that means for us, an acute angle is between 0 and pi over 2. And an obtuse angle is going to be between pi and pi over 2. Okay? So, and I guess we would say between 90 degrees and 180 degrees. So, I'm less worried about you remembering these than about thinking about these radian definitions. A straight angle is pi radians. A right angle is pi over 2 radians. And if you've ever taken a foreign language, you may have heard your foreign language teacher say, or you may have done, I'm just gonna translate what they're saying to me from Spanish into English in my brain, and then I'm going to think of my answer in English, and then I'm going to translate that English back into Spanish. And, I certainly heard it from all of my language teachers. No, don't do that. That's crazy. You need to start learning how to think in Spanish, right? Don't translate to English, write in English, and then translate back into Spanish. Just think in terms of Spanish. and so too here. Don't be that student who is taking theta equals pi over 3 radians and converting that into degrees and then trying to find the coterminal angle for it. That's going to be crazy. I mean, you should be able to do that, but that's going to be crazy. You really just need to know what that is. It's on your unit circle. Okay, so please know your radians. Don't translate from radians to degrees and then do the math in degrees and then come back to radians. That is such a time waster. Okay, don't do that. I mean, so if I'm looking for a coterminal angle here, right? This is what student does. They say, okay, pi over 3. If there's a conversion factor. What's the conversion factor to go from radians to degrees? Well, I know that 2 pi radians is the same as 360 degrees. Okay, and so how does that help me here? Well, what I want to do is I want to multiply this by a conversion factor that will go from radians to degrees. And so I want to use 360 over 2 pi. Though you could also use, and I actually prefer this, 180 over pi. Because look, you can take a 2 out of each of those. Because then the pi's cancel, and I'm left with 60 degrees. So this is 60 degrees. Great. So now, okay, I've gone from radians, I'm now in degrees, and I have to add once around. So I'm going to add 360, because there are 360 degrees in once around the circle. So now that gives me 420 degrees. Oh, but wait, that's in degrees, and I was given radians, and now I have to convert back. So I'm going to convert by multiplying by pi over 180. Okay, so what happens then? Well, there's no canceling pi's, but I can take out 60. So that's going to be 3, and that's going to be a 7. So I end up with 7 pi over 3. Ta-da! So how did I do that problem? I took the radians, I converted from radians to degrees, I added once around, I got 420 degrees, and then I had to convert back from degrees to radians by multiplying by this conversion factor, just to get that. Now, tell me, really? You're going to do that rather than just say pi over 3 plus 2 pi? I mean, come on. Don't do this. I know it feels like, but I'm drowning, Mr. Rupa. This is all I can do is convert. No, stop. Stop it. Stop it, stop it, stop it. If you're looking for coterminal angles and you're given radians, add 2 pi, subtract 2 pi. Now, if I'm given degrees, if they tell me that theta is 27 degrees, and they ask me for a positive coterminal angle, sure, 27 degrees plus 360 degrees is 387 degrees. And there's a positive coterminal angle. Great, that's fine. They gave me degrees, I use degrees. But if they give me 7 pi over 4, and they want a positive coterminal angle for that, I'm doing 7 pi over 4 plus 2 pi to get 15 pi over 4. And how did I do that quickly? Well, if I make a common denominator, that's 8 pi over 4 plus 7 pi over 4 for 15 pi over 4. Please do not turn that into degrees. No, don't do it. Really, this class is so much harder the longer you cling to converting. Now, that being said, yes, you should definitely know how to convert. We know that 2 pi equals 360 degrees. We also know that pi equals 180 degrees. And if I want to go from degrees to radians, I'm going to take theta times pi over 180 degrees, because then the degrees can cancel and I'll have some pi radians. If I want to go from radians to degrees, my conversion factor is going to be 180 over pi. I always want to take whatever, I always want what I want. I want degrees. That's the thing that goes on top. Oh, I want radians. Radians goes on top. Okay? So you should be able to convert, but please, after today, don't rely on that. Really just think in terms of radians, think in terms of degrees. You'll be a much happier camper than that. Okay, but I think I need to say a little more about radians, because all the radians we've looked at so far have a pi in them. And not all radians have pi's in them. Okay? So remember how we said that 2 pi was 360 degrees, and this was 2 pi radians? Okay, so now what I want to know is how many degrees are there in not 2 pi radians, but in 1 radian? So I'm going to divide both sides by 2 pi. Tink, tink, and that gives me 1. 1 radian equals 360 divided by 2 pi. Well, I just happen to have a calculator here, and my calculator says that if I do 360 divided by 2 pi, I end up with 57.2957795 degrees. That's what 1 radian is. Now, I bring that up for a number of reasons. One is so we can understand this visually, like what's going on here visually. Okay, so remember that unit circle? I'm sorry, unit circle. Okay, we've got this unit circle. In fact, draw the circle and then put the axis. Much better circle. So we know that this is 90 degrees, and this is 0 degrees, and this would be about halfway, 45 degrees. And so we're looking over here, and we're saying that that is 1 radian. Okay? That amount of rotation is 1 radian. 1 radian. See, there's no pi next to that. It's just 1 radian. Theta equals 1. That's 1 radian. Now, in degree land, that's also 57.296 degrees. Well, I certainly don't want to be using this as a conversion factor. Oh my goodness. But I do want to be able to visualize what's going on here. Like, okay, so that's 1 radian. Here's another radian. So that's another 57.296 degrees. And so now we're at, 115 something degrees. Oops, a little too high on that. 115 point something, right? 57 plus 57. I'm going to get 115 here. Ish. And then this is 3 radians, right? 1, 2, 3 radians. And so I'm adding another 57 to that, and I'm getting 162-ish degrees. Okay, but look, a little more. This is pi radians, or 3.14159 radians. Oh, I see. So a radian is about that much, and I can put 3 full ones and a part of a radian in here, and that's going to be the same as pi radians. So what happens if they say, hey, find a coterminal angle when theta equals 2? That's not 2 degrees. If we wanted 2 degrees, we'd have to have that symbol there. When I see this is 2 radians. And how do I find coterminal angles? Well, I add 2 pi. There's my positive coterminal angle. And my negative one, I subtract 2 pi. There's my negative coterminal angle. No, I'm not simplifying it. I'm not going to decimalize it. If I'm asked to, I will, but I'm going to have to pull out a calculator for that. So no, there's a positive coterminal angle, there's a negative coterminal angle. All that stuff still works the same. Add or subtract once around to find coterminal angles. Great. No pi here. I know all the angles that are in radians on your unit circle have pi's, but that's not all the angles. Okay? So 2 radians. That's this angle over here, 2 radians. Here's my negative coterminal angle when I subtract 2 pi. And here's my positive coterminal angle when I add 2 pi. Fabulous. Okay, so how's your brain? Is it still alive? Are you able to do this? Let's check. There's one last set of vocabulary that I want to look at with you again. How about complementary angles? When you were younger, you knew complementary angles as 2 angles that add to 90 degrees. Well, yeah, okay, but all the cool kids are saying 2 angles that add to pi over 2 radians. And so I might actually want a formula. Complement plus theta equals pi over 2. 2 angles that add up to be pi over 2. This is the angle I was given. This is the complement I'm looking for. And so my complement is going to be pi over 2 minus theta. That's my recipe for complement. If someone tells me pi over 3 is theta, what's the complement to pi over 3? Well, I know the complement is pi over 2 minus theta, pi over 3. 3 pi over 6 minus 2 pi over 6. I get 1 pi over 6. I can even see that visually. Look. This is pi over 2. This is pi over 3. And so if I do pi over 2 minus, take all this away, what am I left with? Yeah, that's that pi over 6 wedge. We're used to seeing it over here. But that amount of rotation is exactly what we're left with over here, pi over 6. Okay, so we've got a recipe for finding complementary angles. How about supplementary angles? Before you said that supplementary are 2 angles that add up to 180. Yeah, that's true. A supplement and an angle add up to 180. Yeah, except in our class, mostly we talk about radians. And so instead of 180, instead of thinking about 2 angles that add up to 180, I'm thinking about 2 angles that add up to pi. And so my supplement is going to be pi minus theta. If they tell me that theta is 3 pi over 4, and they want to know what the supplement is, well, that's just going to be pi minus theta, or pi over 4. Hey, what if they want to know the complement of 3 pi over 4? Okay, so that formula was complement equals pi over 2 minus theta. And so in our problem, pi over 2 minus 3 pi over 4. I guess I have to make a common denominator here. I'll multiply by 2 over 2. And so that's 2 pi over 4 minus 3 pi over 4 is negative pi over 4. And guess what? That's wrong. So let's go back to these definitions and say that complementary angles are 2 positive angles that add up to pi over 2, or if you must, 90 degrees. And supplementary angles are 2 positive angles that add up to pi, or if you need, 180 degrees. Have to be positive angles. Why didn't we talk about this in the 8th grade or in geometry class? And the answer to that question is because you didn't know we could have negative angles. And generally, in degree world, we're talking about, oh, the ramp makes a 27-degree angle. Ramp. And we don't have negative angles like that. It's only when we really start thinking about rotating in the opposite direction that there's much of a need for negative angles. And therefore, we can just, to those younger kids, define as 2 angles. Okay, but for us, it's got to be 2 positive angles. So what about that problem I just asked you about, where I gave you theta equals 3 pi over 4? We found that the supplement was pi minus 3 pi over 4, or pi over 4, because we used that formula for supplement, pi minus theta. But when it came to the complement, and we used pi over 2 minus 3 pi over 4, we ended up with negative pi over 4. No. Complements have to be positive. So what do we say? We say this has no complement. Okay, and are we confused by that? No. And here, let me show you why. So let's take a look at this. Okay, that's a right angle. Okay, complementary angles are 2 angles that add up to a right angle. Okay, here's 3 pi over 4. This angle is already bigger than 2 angles add up to that amount. How much bigger? Pi over 4 too big. So anytime I go past here with my angle, that's never going to have a complement. Complement has to be something in here. 2 angles in here, in first quadrant, that add up to pi over 2, or that add up to 90 degrees. 50 degrees and 40 degrees, great. But 120, 135 degrees? No, that's too big. Complement stops at 90. Complement stops at pi over 2. Okay? Wow, so we've just redefined all your geometry knowledge. I think that's great. Remember, acute, obtuse, right, straight in terms of radians. Remember those amounts of rotation on your unit circle. Remember there's a conversion factor if you need it. Pi over 180 if you're going from degrees to radians, and 180 over pi if you're going from radians to degrees. Try not to use this, really. Try not to use this. There will be some problems that you face in the next couple of days where they ask you explicitly to convert, but that's really the only time. You should be able to find supplements. You should be able to find complements. You know that this is pi equals theta plus its supplement, and this is pi over 2 equals theta plus the complement, and so therefore supplement is pi minus theta, and complement is pi over 2 minus theta. You know to find coterminal angles. You know what they are. They start and end at the same place. But we're just going to add or subtract 2 pi to make those coterminal angles. And if someone wants us to do it with degrees, we're going to add or subtract 360. Okay, I think there's a lot of stuff there. That's plenty good for me. Yeah, let's see how that works. Please let Mr. Paz know if you have any questions about this stuff. And I look forward to seeing you in our next video. I just changed my mind. Hold on. So, if they say draw 5 pi over 7. So, a lot of people have some difficulty with this. And here's what I want to say. I want to say that you should take these quadrant angles and give them the same denominator. Like make a common denominator for these things. So I'm going to multiply by 2 over 2. I'm going to multiply by 7 over 7. Okay, so what am I getting? I'm getting, this is 7 pi over 14. This is, I want a common denominator, so I need 14 over 14. This is 14 pi over 14. Okay, 7 pi over 14, 14 pi over 14. This is, oh, and this one here would be 21 pi over 14. And over here we have 28 pi over 14. And what they're asking us to do is to draw 10 pi over 14. So is 10 pi over 14 here between 0 and 7 pi over 14? No, 10 is bigger than 7. Is 10 pi over 14 in this quadrant between 7 pi over 14 and 14 pi over 14? Why, yes. Yes, it is. And it's 3 away from this one, but 4 away from this one. So I think it's going to be more like that than like this. Yeah? A little closer to this one than it is to that one. And so there's my 5 pi over 7. Okay? Okay. Likewise, if they give me draw, yeah, no, I'm not going to do that. I'm going to say draw 4 radians. Okay. This is pi radians. That's 3.14159 radians. Well, 4 radians? It's just going to be a little past that. There we go. This is 1.57 radians. This is 3.14 radians. This is 4.5 times pi, 4.71 radians, and this is 6.28 radians. And oh, by the way, we should still be doing 3 decimal places, all right? 3 decimal places is the standard, so let me put a 3rd decimal place there, 1.7571. Okay, and 6283. Great. So there's my theta. Theta equals 4 radians. Got that. Doesn't have to be more precise than that. You should never need a protractor or a compass in this class. Okay? All right, now I really can be done. Thanks for the extra 2.5 minutes. Have a nice day.